If you're curious about the technology behind manufacturing and using steel cables, then come explore it with me. Inside a modern industrial workshop, the production of giant crane cables takes place through a carefully organized sequence of operations. The process begins with massive coils of high-strength steel wire being delivered to the facility. Heavy machines unwind the raw material and feed it into powerful forming equipment. Skilled technicians monitor every stage, ensuring that each strand meets strict engineering standards. Multiple wires are drawn together and twisted with extreme precision to create the core structure of the cable. Enormous rotating drums slowly combine dozens of individual strands into a single, incredibly strong unit. Throughout the workshop, hydraulic presses, automated cutters, and computer-controlled winding systems work continuously under the supervision of experienced operators. Sparks fly and engines roar as the components gradually take shape. Workers wearing protective gear guide the material, adjust the tension, and inspect the surface for any imperfections. Quality control is a constant priority, and specialized instruments measure diameter, flexibility, and load capacity. The scale of the equipment highlights the demanding nature of the task. Overhead cranes transport the growing cables from one station to another, while forklifts move heavy reels across the floor. Each completed section is carefully coated and prepared for final assembly. Teamwork between advanced machinery and human expertise is essential to transform simple steel wires into reliable lifting tools. After thorough testing, the finished products are packed safely and made ready directly for shipment to construction sites and shipyards around the world. The operation demonstrates modern industrial craftsmanship. The installation of the giant Sling system, capable of lifting more than 24,000 tons, marked a milestone in offshore construction. The process began with the placement of the horizontal top part, followed by the roll-up of the bottom section in row 1. Despite earlier delays and rising costs, the assembly phase was executed with remarkable efficiency. Within just 5 days, all 4 massive modules were installed, each representing a crucial element of the platform's overall structure. The challenge intensified as the project moved offshore, where the modules had to be transformed into a single integrated platform. These 4 modules, once interconnected, formed a colossal structure exceeding 24,000 tons in total weight. To achieve this, vast amounts of steel, pipes, and cables were meticulously joined together, ensuring strength, stability, and functionality. The complexity of this task required precision engineering and close coordination among teams, as every connection played a vital role in the platform's performance. Ultimately, this installation stood out as one of the most significant platform assemblies undertaken within the Equinor system in many years. It highlighted not only the scale of modern offshore projects, but also the capability of advanced sling technology to handle extreme lifting operations. The SGC-250 is recognized as the largest beam crane in the world and represents a major achievement in modern heavy lifting technology. Designed for extremely demanding industrial projects, This giant crane operates on a circular ring base that provides outstanding stability and mobility on large construction sites. The structure has been engineered to handle extraordinary loads with maximum precision and safety. One of the most impressive features of the SGC 250 is its enormous counterweight system. It uses a total of 4,000 tons of counterweight, which are arranged in 42 specially designed containers positioned around the ring. This massive ballast allows the crane to lift components that no other conventional crane can manage. To ensure reliable performance during long and complex operations, the crane is equipped with a fully integrated cooling system. This advanced system continuously regulates the temperature of critical mechanical and hydraulic components, preventing overheating and reducing wear. The SGC 250 also meets strict environmental standards and is fully Tier 4 compliant, making it suitable for use in regions with demanding emission regulations. Every movement of the crane is controlled by sophisticated computer systems and highly trained operators. Thanks to its modular design, the crane can be transported in sections and assembled directly on site. With its unmatched lifting capacity, innovative engineering, and intelligent safety features, the SGC 250 has become an essential solution for constructing refineries, offshore platforms, bridges, and other megastructures around the world. Proven worldwide successfully. The TCC 7800 is one of the most powerful heavy lift cranes in operation today, designed to handle extremely large and demanding loads with precision and reliability. Installed at the port of Rostock in Germany, this rail-mounted gantry crane plays a crucial role in modern industrial logistics, particularly for offshore engineering, shipbuilding, and large infrastructure projects. Thanks to its advanced engineering and robust structure, the TCC 7800 is capable of lifting extraordinary weights that exceed 600 tons, making it a vital machine for oversized and high-value cargo operations. The main hoist of the crane offers a maximum lifting capacity of 600 tons at a radius of 36 meters, allowing it to move massive components safely and efficiently. In addition to its impressive strength, the crane provides an outstanding maximum lifting height of 112 meters, enabling it to handle tall and complex structures. To further increase its flexibility, the TCC 7800 is equipped with 2 auxiliary hoists. Auxiliary Hoist 1 can lift up to 490 tons at a 92-meter radius, while Auxiliary Hoist 2 is designed for lighter operations, offering a capacity of 25 tons at a 105-meter radius. When fully luffed, the crane reaches a remarkable total height of 164 meters, giving it exceptional reach and operational range. Mounted on rails, it can travel along the quay to position itself precisely where needed, improving efficiency in port handling. Built to manage large-sized goods from a wide variety of industries, the TCC 7800 represents cutting-edge lifting technology. Its combination of enormous power, stability, and versatility makes it an essential asset for heavy transport and construction projects around the world. The Hendrik Vader Group has expanded its rental fleet with 12 identical steel lifting slings, each measuring 61 meters in length and 0.36 meters in diameter. The production of these massive slings represents a combination of traditional craftsmanship and advanced machining precision, ensuring that every detail meets the demanding requirements of heavy lifting operations. The process began with thorough engineering, where detailed specifications were drawn up to match the intended application. Once the design phase was complete, the focus shifted to the supply chain. To guarantee consistent quality, the steel wires required for these slings were sourced from Asia. Their delivery was carefully scheduled using a just-in-time approach, allowing the production team to meet tight deadlines while avoiding unnecessary stockpiling of materials. After arrival, the wires underwent strict quality checks before being processed. Skilled technicians, supported by advanced machinery, carried out the intricate steps of braiding and forming the slings. Precision was essential at this stage, as the strength and durability of each sling depended on the accuracy of the splicing and mechanical finishing. The integration of handwork with machine-assisted processes created a product that combined reliability with efficiency. Throughout production, continuous monitoring and inspections were conducted to ensure every sling adhered to both internal standards and international safety regulations. The result was a set of 12 robust lifting slings, uniform in size and performance, ready to be deployed in challenging lifting operations across industries. By successfully completing this project, the Hendrik Vader Group once again demonstrated its expertise in producing high-quality lifting solutions, while also showcasing its ability to coordinate complex supply chains and deliver specialized products on time. The production of wire sling ropes begins with the preparation of raw steel cables. Large coils of finished wire rope are delivered to the workshop and placed in unwinding racks. Each coil is carefully unrolled, and individual lengths of cable are pulled out by workers. According to the required order size and technical specifications, the cables are measured and cut into sections of appropriate length. This cutting stage is very important because every sling must match precise dimensions in order to work safely in industrial lifting operations. After cutting, several pieces of cable are laid out straight and arranged neatly. Workers align them side by side to ensure that there are no twists or deformations. Using measuring tools, the operator marks specific points along each cable where the eye loops will later be formed. These points are indicated clearly with spray paint so that they remain visible during the following steps. Accurate marking guarantees that every sling produced in the batch will be uniform and consistent. The next stage is the mechanical formation of the cable sling eyes. A metal ferrule, often made of aluminum or lead, is inserted onto the end of each steel cable. The end of the cable is then bent back and passed through this ferrule to create a loop. Once the loop is correctly shaped, the prepared cable is taken to a hydraulic pressing machine. The machine applies extremely high pressure to compress the ferrule tightly around the cable strands. This compression locks the cable securely in place and forms a strong, permanent eye at the end of the sling. Each sling undergoes the same procedure on both ends so that it can be attached to hooks, shackles, or lifting equipment. The hydraulic press ensures that every connection point is solid and capable of carrying heavy loads without slipping. After pressing, the operator visually inspects the finished eye to check that the ferrule is properly formed and that no wires are damaged. Any sling that does not meet quality standards is rejected or reworked. When all necessary pressing operations are completed, the individual wire sling rope is considered structurally finished. Under the skilled hands of the workers, multiple strands of cable are combined and secured to create a strong lifting tool. The compressed ferrules act as reliable anchor points, preventing the rope from unraveling during use. At this stage, the product is a complete mechanical wire sling ready for final handling. The finished slings are then collected from the production area. They are stacked together according to size and type, and workers bind them into bundles for easier transportation. These bundles are moved to the storage section of the factory, where they await packaging and shipment to industrial customers. This completes the machine-based mass production process, which allows large quantities of identical and highly durable wire slings to be manufactured efficiently. In addition to mechanical production, wire sling ropes can also be created entirely by hand. The manual method requires more time and craftsmanship, but it remains useful for special applications or custom-made products. The handmade process begins in a similar way, with a standard steel cable being selected and measured. Instead of using cutting and pressing machines, the worker relies mainly on hand tools and personal skill. To start the manual method, the craftsman separates the end of a finished cable into individual strands. Using strong hands and simple tools, he untwists a portion of the rope, carefully dividing it into two main parts. This separation allows the creation of a traditional spliced eye without the need for metal ferrules or hydraulic equipment. The next step is forming the eye loop at one end of the cable. The worker bends the rope back on itself to create the desired loop size. Then the loose strands are woven and braided back into the body of the cable. Each strand is threaded alternately, over and under the existing strands in a precise pattern. This splicing technique requires experience and attention, because the strength of the sling depends entirely on the quality of the weave. The same procedure is repeated on the opposite end of the rope so that both ends have secure, hand-spliced eyes. During this process, the small steel wires that make up each strand are twisted tightly around a central core, gradually rebuilding the structure of the cable. The worker pulls and tightens every strand to make sure that the splice is compact and firm. No machines are used. Only manual force and traditional methods ensure the final strength. After both eyes have been formed and inspected, the manual production of the wire sling rope is finished. Although this method is slower than hydraulic pressing, it produces flexible and reliable slings that are still widely used in many workplaces. Each handmade sling reflects the craftsmanship of the worker who created it. Through these two different methods, mechanical mass production and traditional hand splicing industrial sites are supplied with essential wire sling ropes. Whether produced by powerful machines or by skilled hands, every sling must follow a careful sequence of steps to guarantee safety, durability, and dependable performance in heavy lifting operations. The non-contacting, non-destructive evaluation of steel wire rope begins with a specialized rope-moving machine that guides the cable through the inspection system. Technicians prepare the process by carefully attaching wires to the rope to ensure stable movement and accurate tracking. A critical factor is the air gap, also called liftoff, maintained between the rope and sensor head. This precise spacing allows electromagnetic sensors to detect internal flaws, broken strands, corrosion, and wear without physical contact. Continuous monitoring provides data while preventing damage to the rope surface, making the method safe and efficient for applications. Inspection and load testing on an Ingersoll Rand air winch are essential procedures to ensure safe and reliable operation in industrial environments. The process begins with a detailed visual inspection of the winch structure, including the drum, housing, air motor, and control valves. Technicians carefully examine wire ropes, hooks, and connection points for signs of wear, corrosion, or mechanical damage. Lubrication levels and air supply lines are also checked to confirm that the system is prepared for testing. After the preliminary inspection, the winch is connected to calibrated testing equipment. A series of functional tests are performed to verify smooth rotation, proper braking performance, and accurate response to control inputs. The load test is conducted by gradually applying weight to simulate real working conditions. Operators monitor pressure gauges and lifting speed to confirm that the winch meets manufacturer specifications. Any unusual noise, vibration, or loss of power is recorded for further maintenance. Successful completion of the test demonstrates that the equipment can operate effectively within its rated capacity. Regular inspection and testing help extend service life, reduce unexpected failures, and protect personnel. These procedures ensure that Ingersoll Rand air winches deliver reliable performance in service. At the Aspire Apartments on King Street in Melbourne, Hickory Constructions is using a 4.5-ton electric hydraulic winch for lifting operations inside the lift shaft. The winch was delivered to level 53 by the tail crane and placed on a roll dock before being moved into position on jacks. Workers utilize the winch to raise the production deck within the shaft. The winch rope runs through sheave blocks to the top of the shaft and back down, forming a two-part line for efficient lifting. This is the 5th or 6th time the equipment has been used at the Aspire Apartments. The hydraulic winch is powered by a 3-phase power unit and provides a line pull capacity of 4.5 tons with 200 meters of rope on the drum. An Archimedes screw ensures even spooling of the wire rope. A built-in overload protection system prevents unsafe lifting. The self-contained unit can be powered up. Inside the production workshop, the anchor chain manufacturing process moves forward steadily. Red-hot steel bars are heated to high temperatures and then transferred into heavy-duty bending machines. These machines gradually curve and press the glowing metal into the required shape. Each bar is carefully bent and formed into a strong individual chain link. Precise alignment and shaping ensure that every link meets strict dimensional and quality standards. Over many decades of operation, the Beloretsk Metallurgical Combine, BMK, has produced nearly 3 million tons of wire rope products. If laid end-to-end, this amount of rope could wrap around the Earth's equator more than 60 times. Today, every third wire rope used on the Russian market is manufactured at BMK. Closely monitoring market demands and responding flexibly to customer needs, the company plays a key role in supplying critical rope products for various industries. At present, domestic mining enterprises face an urgent need for import substituting high-performance wire ropes, including ropes with polymer coatings. In mining operations, excavators, both domestic and imported, rely heavily on the reliability and durability of hoisting and traction ropes, which are among the most critical components of the machine. In some cases, the service life of conventional excavator ropes is less than 1 month. This leads to high rope consumption, frequent downtime, and a significant increase in mining costs. According to specialists, the main cause of excavator rope failure is mechanical wear during operation. Therefore, excavator ropes must resist external friction and impact loads, maintain high tensile strength, and remain flexible. These requirements are best met by multi-strand wire ropes with polymer coatings. Until recently, such ropes were not produced in Russia and were mainly used on imported excavators. Today, BMK is actively developing this import substituting product with the support of the Industrial Development Fund of the Russian Federation. The plant has mastered the technology for producing steel wire ropes with polymer coatings that match conventional steel ropes in breaking strength while offering several important advantages. First, the polymer layer prevents direct contact between the rope wires and the surfaces of sheaves and pulleys. This increases the contact area and significantly reduces mechanical wear of both the rope and the equipment components, whose replacement is far more expensive and time-consuming than replacing the rope itself. Second, the polymer separates individual strands within the rope, preventing internal wire abrasion and extending service life. Third, the load is distributed more evenly among the strands, making the rope less sensitive to dynamic shock loads and transverse crushing. In addition, the polymer-coated surface provides improved corrosion resistance. To validate these advantages, BMK conducted extensive field tests. A 39 mm, 45.5 mm, 52 mm, and 57 mm polymer-coated ropes have already undergone industrial trials. Special attention was given to a 9 mm rope installed on an EKG-5 excavator at a limestone quarry. Weekly inspections were carried out over several months. The rope operated for more than 5 months in temperatures ranging from +5 degrees Celsius to -38 degrees Celsius, outperforming standard ropes without polymer coatings by approximately 1.5 months. Overall, the trials confirmed that polymer-coated multi-strand ropes significantly reduce equipment downtime, lower maintenance costs, and improve operational efficiency. Based on these results, BMK plans to expand production of ropes with up to 12 outer strands in diameters up to 90 mm, targeting applications in mining, machine building, bridge construction, shipbuilding, and the oil and gas industry. The Cabmach Armoring Line RS24 plus 32/630 is a modern industrial system designed for the high-speed screening and armoring of power and control cables. This advanced production line provides manufacturers with a reliable and flexible solution for applying protective metallic layers to cable cores. The commissioning of the line represents the final stage of installation, testing, and operational handover to the customer. During mechanical installation, core components such as single or dual cage configurations are assembled to enable round wire armoring or copper wire screening. Each element is carefully aligned to guarantee smooth and stable operation. Control system integration is a critical phase in which dancer controls and torque controls are calibrated to maintain accurate tension throughout the process. This ensures consistent product quality, even at high production speeds. The taping head setup allows different types of metal or steel tapes to be applied precisely around the cable core, according to technical requirements. After all systems are configured, comprehensive operational testing is performed. The line is run at various speeds to verify rotation performance, measured in revolutions per minute, and to confirm the integrity of the laying up process for steel or aluminum wires. Once all parameters meet industrial standards, the Cabmach screening armoring line is ready for full production, delivering efficient, safe, and high-quality cable manufacturing capabilities for demanding electrical and energy applications worldwide today. The SDIII Hill Cable Factory is a modern enterprise specializing in the manufacture of high-quality electrical cables and wires. Our plant combines advanced technology with professional experience to deliver reliable products for industrial and commercial applications. From the arrival of raw materials to the final packaging stage, every step of the process is carefully organized and strictly controlled. Automated equipment, skilled engineers, and trained operators ensure stable performance and consistent standards. The company invests in new machinery, quality control systems, and staff development. As a result, Steel Cable Plant successfully meets customer requirements and international regulations. We are proud to present our capabilities and invite you to discover the efficient world. Overhead cables play an essential role in the modern transmission and distribution of electrical energy. As cities expand and power demand increases, reliable aerial cable systems become increasingly important. ZMS Cable, a professional overhead cable manufacturer and supplier, specializes in the design and production of high-quality cables for power networks around the world. The company focuses on providing durable and efficient solutions that meet international standards. Overhead cable is a new type of electrical product widely used for transmitting electric power through overhead lines, especially in urban reconstruction projects and in forest regions. The manufacturing process begins with the careful selection of raw materials, such as high-purity aluminum conductors and high-strength insulating compounds. These materials are processed using advanced extrusion, stranding, and coating equipment to ensure excellent electrical conductivity and mechanical performance. Modern production lines allow precise control of cable diameter, insulation thickness, and overall quality. After forming the conductors, protective layers are added to resist weather conditions, ultraviolet radiation, and mechanical stress. Strict testing procedures, including voltage resistance and tensile strength tests, are carried out at every stage to guarantee safety and reliability. Overhead cables produced by ZMS Cable are designed to improve the safety and reliability of electrified wire networks. Compared with traditional bare conductors, these cables reduce the risk of short circuits, power loss, and accidental contact. They are extensively used in rebuilding old power grids, expanding rural electrification, and constructing new transmission routes. The flexibility and lightweight structure of the cables also make installation faster and more economical. With continuous technological innovation, the company provides customized solutions for different climates and environments. Through professional manufacturing experience and advanced technology, ZMS Cable supplies dependable aerial cables to customers worldwide, supporting stable and efficient power distribution systems everywhere across many important industrial and residential applications today. The 1000 volts aerial bundled cable is an advanced overhead power cable designed to safely transmit electrical energy in low voltage distribution systems. Unlike traditional bare conductors, this cable bundles multiple insulated cores together, reducing the risk of short circuits and improving overall reliability and safety. Rated for up to 1000 volts, it is commonly used as a service drop cable from power poles to building entrances, construction sites, or street lighting, and offers easier installation with lower maintenance needs than conventional overhead lines. The insulated design also minimizes power losses and enhances performance in urban and rural distribution networks. Constructed with aluminum conductors and durable insulation materials such as XLPE, it provides robust performance in various environmental conditions. The Hendrick-Vader Group operates at the heart of dynamic industries where heavy lifting, towing, and mooring are essential. Wherever major projects are taking place, reliable ropes and lifting equipment are required, and this is where the company plays a crucial role. The group specializes in providing high-quality steel wire ropes and advanced fiber ropes, serving mainly the offshore and maritime sectors, while also supporting many other industrial fields. With a proud history dating back to 1545, the company has grown alongside centuries of technological progress. From the age of legendary naval explorers to the modern era of offshore engineering, Hendrick-Vader has continuously adapted to new materials and methods. Today, the group combines traditional expertise with modern innovation, working confidently with materials such as manila, polyester, Dyneema, and especially steel, which remains its primary focus. The organization unites a team of technical specialists with a strong and experienced sales network that stays close to customers around the world. This combination enables the group to act as a single, reliable source for all steel wire and fiber rope requirements, as well as for related lifting and towing equipment. Hendrick-Vader designs and manufactures custom steel wire rope slings and grommet slings capable of handling the most demanding tasks. Before products are delivered, they undergo strict proof load and braking load tests of up to 250 tons to guarantee safety and performance. Additional services include spooling, reeving, inspections, and certification to ensure proper operation throughout the product lifecycle. With more than 3,000 items in stock across European warehouses and a global supplier network, the company can respond quickly to customer needs. Driven by adventure and challenge, the Hendrik Vader Group continues to earn the trust of industry leaders. Its ISO-certified processes and skilled professionals have achieved remarkable results, including the production of a record-breaking 280-meter cable-laid sling, an outstanding example of engineering excellence.